Chapter 9, Section 2, Reflections. Now a reflection across a line M, so a line reflection, where a line M is called the line of reflection, is a transformation in which if a point A is on line M, then the image of A is itself. So we can see here, point A is on line M, so A prime is just itself. When it reflects, it's on the line of reflection, so it stays itself. But if a point B is not on line M, then M is the perpendicular bisector of line B, B prime. So this is a line B, B prime. So if a point B is not on line M, here point B is not on line M, then M, line M, is the perpendicular bisector of the line that connects B, the pre-image, with B prime, the image. So when you have a reflection, the pre-image point and the image point, if you connect them into a line and they're not on the line of reflection, then the line of reflection should be the perpendicular bisector of the segment that connects them. So you can see that this piece and this piece are congruent and it makes a right angle with the line that connects them. This is going to be important for constructions when we get to that. So a reflection is a rigid motion. So we have another rigid motion here. Under a line reflection, distance, angle measure, collinearity, and midpoint are all preserved. However, orientation is not preserved. Therefore, a line reflection is an opposite isometry. So if we try an example, we're going to do a few different types of reflections. The first one is a reflection over the x-axis. So please make a note of that. If you have to title it, reflection over the x-axis. The rule for this is, if you're starting off with the point xy, a reflection over the x-axis, you're going to keep the x value but negate the y value. So in this example, and this should be done on graph paper, point A is -2, 1. So in the reflection, we're going to keep the x value but negate the y value. So A prime is -2, -1. B, it was 2, 4. B prime is going to be 2, -4. C was 4, 2. C prime is going to be 4, -2. So you keep the x and you negate the y value. If it was a negative y value, you would make it positive. And if it was positive, you make it negative. If you forget the rules for reflections when graphing, you only need to fold your paper along the line of reflection or find the line of reflection, which in this case is the x-axis. Point A is 1 unit up, so A prime will be 1 unit down. B is 4 units up, so B prime will be 4 units down. C is 2 units up, so C prime will be 2 units down. So even if you forget the rules, if it's on a graph, you can still use the axis of symmetry to see how far it is away from that line of symmetry. The next type of reflection is across the y-axis. Now this is a very similar rule, but make sure you memorize these rules. If you start off with coordinates x, y, you keep the y and you negate the x. So it's the opposite of what we did when we reflected across the x-axis. So if we're starting with point A as 2, 2, we keep the y and negate the x, so -2, 2. 4, 4, keep the y, negate the x, so -4, 4. 5, 1, keep the y, negate the x, so -5, 1. Again, if we look at the line of symmetry, which is the y-axis, A is 2 points to the right, A prime is 2 points to the left. B is 4 points to the right, B prime is 4 points to the left. So they should line up, in case you forget the rule. The next two types of reflections we're going to talk about is a reflection across the line y equals x, which is this direction. When you're reflecting across the line y equals x, the x and y values switch places. So in this example, we started with -4, 2. They switch places, so it becomes 2, -4. -3, -1, switch places, -1, -3. -5, -2, switch places, -2, -5. And that's our pre-image and our image after we reflected across the line y equals x. Now in the other direction, across the line y equals -x, you switch the coordinates, but you also negate them. So if we reflected from the pre-image, so if we started with the pre-image, triangle ABC, and reflected it across the line y equals -x, we would switch the coordinates for A. So A started off as -4, 2. When we switch them, we get 2, -4, but we're also going to negate them. So -2, +4. And this would be our A, let's say double prime in this case because we're doing a different figure. Same thing with B. It started off as -3, -1. When we switch and negate them, B double prime would be 1, 3. And then C started off as -5, -2. So when we switch them and negate them, we get +2, +5. And then we would connect them. So in this case, we have an image and a pre-image and 2 images because we did 2 separate reflections on the same graph. Now the last type of reflection that sometimes comes up is a point reflection. So you're not reflecting across a line, you're reflecting across a point, and that point is usually for our purposes the origin. So a reflection about the origin of xy, what happens is you just negate both of the coordinates. So if we're starting with triangle ABC as the pre-image, triangle A prime, B prime, C prime would be the image, and what happens is 1, 4 becomes -1, -4. 1, 2 becomes -1, -2, where the origin is the midpoint of the segment. So rather than the line of reflection, which is the perpendicular bisector of the segment that connects the point in the pre-image with its point in the image, here it's just the midpoint. So if we have line segment A prime, A to the origin is congruent to the origin to A prime because this would be the midpoint of that segment. Now, when reflecting over any line, each point of a reflected image is the same distance from the line of reflection as the corresponding point of the original figure. So in other words, the line of reflection lies directly in the middle between the figure and its image, between the pre-image and its image. It's the perpendicular bisector of the segment joining any point to its image. So joining any point, let's say A, to its image, it's the perpendicular bisector. So again, we see perpendicular bisectors coming up. So this is something that could be asked as a construction. Keep this idea in mind when working with lines of reflections that are neither the x-axis, nor the y-axis, nor y equals x or y equals -x. So those 4 rules you should have memorized. But in any case, if they say the line of reflection is x equals -2, all you have to do is make sure that it's bisecting the line that connects the points. So A to B, this is 3 units long, and this is 3 units long. C to C prime. Here we have 3 units, 3 units. And B to B prime, 1 unit and 1 unit.